Okay, for our next stop, we are in near the town of Manitowish Waters. So this is south and east of where we've been for most of the trip. And driving along the road, you see this outcrop of rock, which might first look like sort of a nondescript gray rock, as many rocks do. But let's get up closer and have a look. All right. Here's a nice piece. As you look at this rock, you can immediately see that there are some large crystals in here. You might identify some of the minerals. You've got a sample of this, so take a couple minutes and try to identify some of the minerals in the sample that you have. And then we'll talk a little bit more about what you see here. Okay, so after looking at your sample of this rock, one of the things some of the minerals you might have noticed, probably one of the ones you first to notice might have been the mineral biotite. So you see some nice larger grain biotite crystals in there. There's also a blue blady mineral, which hopefully you identified as the mineral kyanite. And finally, you might also have identified the mineral garnet present in here. There are also feldspars and quartz present in this rock as well. So you might also notice as you look at this rock that the rock tends to have a nice foliation. You can see this at the outcrop scale. You see some of those lineations and foliations in the rock there. You can also see it when you're looking at a hand sample of this rock. You see these nice black stripes indicating that the minerals have aligned themselves due to pressure. So these are metamorphic rocks, okay? And it turns out, perhaps surprisingly, that this rock you're looking at right here is effectively the Tyler Formation. Okay, so this rock has its origins as the same shale that the slate we saw at the outcrop on the side of Highway 77 has. So this was once upon a time marine muds deposited in the Inimiki Basin that eventually became the Tyler Formation. Now, clearly, this doesn't look like a slate or a shale anymore. Indeed, it doesn't. So this is a biotite garnet kyanite schist. Okay, so this schist indicates that this is a relatively high-grade metamorphic rock. Okay, so these rocks tell a very cool story about the Pinokian orogeny and about the mountains that were built here. So what these rocks tell us is that those muds of the Tyler Formation were buried deep underground, and they underwent a tremendous amount of pressure and heat, altering the mineralogy to what we see in these rocks today. Then, of course, the massive mountain range that was on top of these mountains that was squeezing the minerals into new minerals like kyanite and biotite and garnet, those rocks weathered away, okay? And so what we see here left are these, and these are the highest grade metamorphic rocks in the state of Wisconsin. And what these rocks tell us is they tell us a story about just how large those mountains must have been. And you guys are going to work on some calculations rooted in some studies that others have done to get a sense of just how much rock must have been removed and thus how tall those mountains must have been to yield the kyanite bearing schist that we see here. So these are some very cool rocks indicating just how large this Pinokian orogeny really was. All right.